got the first question on the review packet for Chapter 7. So for this, what we have is which of the following could be lengths of the sides of the right triangle. There's more than one right answer here. So there's several of these that will work, and I'm going to show you exactly what we're looking for on these problems. So they're the sides of a potential right triangle. So we want to find out is a squared plus b squared equal to c squared. Okay, if that actually happens, then we're going to say that it's yes. Okay, but so for A, we're going to test to see if this is going to work, and it's not. Okay, so it's kind of a question mark. That's going to be 3, that's going to be 4, and that's going to be 5. Right now I can tell you that it's not going to work, so we're going to say no to A. B, 15 squared plus 20 squared does, or will equal 25 squared. That's going to be 625 when you type that in. So is that, since it works, that is going to be the 3 sides of a right triangle. C, same thing. Okay, so if anybody's taught you 3, 4, 5 right triangle, because 3 squared plus 4 squared does work, it does equal 5 squared. This is going to as well. That's going to be 25, 250,000. So is this. Since both sides are equal, this one works. So we got to be careful on this one. When you square this, make sure you put the 2 square root of 2 in parentheses. If make a mistake and do 2 square root of 2 squared, it'll only square the square root of 2, which turns it into altogether 4. What should happen is we square both the 2 and the square root of 2. That combines to get us 8. Okay? So that one works, by the way. So that's also a yes. Let's see. Square root of 3 squared plus square root of 4 squared. Does it equal square root of 7 squared? Yes. All right, so that's also a yes. Now this next one's a Pythagorean triple, so that's going to work as well. It's 400 plus 441, so 841, and then that's also 841. Let me just double check that. Pretty sure. Yes, both are 841, so that one works. And this last one's a little tricky, but I think it works as well. I'll come over here. So G. Be careful again. Got to have parentheses around that. So the 2 and the square root of 3 both get squared. 3 square roots of 2, quantity squared, and square root of 30 squared. 4 times 3 is 12. 9 times 2, that's going to be 18. Yeah, that works. So that's also a yes. All right, so all of them except the first one? Yeah. All right, number 2. In the diagram from point A, the angle of elevation. So we talked about this. Line of sight supposed to be parallel to the ground. So let's assume this is the ground. Okay, if you're at point A, you're looking that way. Okay, and then elevate from that line of sight. So that's your 35-degree angle. Okay. So if that angle's 35 and that's 90, you're going to do 35 plus 90, 125, and then 180 minus 125 is 55. So the measure of angle ACB is going to be 55. because that's this angle up here. All right. Uh, this is less work than it looks, but it's a little unusual. So what they're telling us is tangent. Tangent is a function, a lot like this. Okay, let's say we just make this up, 5x minus 1, right? Say a function f does something to x when we plug it in. Okay, change it to 5x minus 2. Here's what that means. Let's say we throw a 2 in there. That means plug 2 in for x under this condition. So 2 in for x. So f of 2 turns into 9. Well, tangent of x does something similar to that. It's a function. We don't know exactly what's going on in there, but we know it turns the angle measure that we plug in into this decimal. And this decimal is the ratio of two sides. So our trig functions, okay, when we plug in an angle measure, okay, the decimal given is the ratio of two sides. Now in this case, it's opposite over adjacent. It doesn't matter. What we have to know is that it's a trig function. When we plug an angle in, it gives us the decimal, which represents the ratio of two sides. So it's 0.7773 over 1. Now, the tricky part is when we want x, we have to know how to do this algebraically. We can't divide by tan. That's not how it works. All right, it looks like it's next to, and we've been taught that that's multiplied, but it's not. Okay, this is a function. To get rid of the tangent function, we have to apply what's called tangent inverse. So I'm going to write down tan x equals 0.7773. Algebraically, what's really supposed to happen here is we're supposed to take tangent inverse, notice, of both sides. I took tangent inverse of that. It's a little strange, okay? But we're supposed to perform the inverse operation. Now, whatever I did to the left side, I should do to the right side. Okay, so when you have an inverse operation and then that operation, so inverse function and the function, what happens is those knock each other out. So now we just have x. And then tangent inverse of 0.7773, we'll type that in our calculator and get, where did that go? What number is this? 3. No, there it is. So 37.857. Okay, and it doesn't say what to round to. Let's just assume then we're going to say it's about 37.9 degrees. I'm assuming it wants degrees, not radians. Okay, so now let's move down to here. Now this is a similar problem, but a little more involved. Now they want the angle x. Now we have to apply a trig function, and then again, the inverse operation to that. What we do for any trig problem is we'll label the sides. That's hypotenuse. This is a leg opposite the angle we're going to be talking about. And this is the leg that's adjacent to the angle we're going to be using. Okay. So to make my decision on a trig function, I am going to have to use tangent. Okay, because opposite and adjacent are involved. So tan x is going to equal opposite over adjacent. Tan of some angle is going to be 7 over 6. I believe that's 1.16 repeating. And again, what we're into is we have to get rid of tan. So to get rid of tan, to get at x, we have to perform the inverse of tangent to both sides of the equation. Okay, so x is going to equal whatever tan inverse of 1.16 repeating is, and it looks like we get 49.3987. Does it say to round? No. So let's assume it's about 49.4 degrees. Okay? All right. That'll be it for this video. Then we'll pick it up on the next one.